the statistics that we're starting right now is called bivariate statistics. All the statistics that you've done so far, you could say is mono or univariate, because all you're looking at is the frequency distribution of one variable. All right? But now, and the more useful statistics, is when you look at the relationship between two different variables. When you're looking at two variables in maths, in science, it's always useful to try to determine the independent and the dependent variable. At year 12, we tend to call the independent the explanatory variable. So the independent variable is the one that causes change in the other variable. You must always put it on the x-axis. You don't get a choice where the independent variable goes. It always goes along the bottom. What is the dependent variable? We call it the response variable in year 12. That's the variable that changes due to change in the independent variable, and that's always on the y-axis. You don't get a choice about that. So if I was to pretend to do a practical where I made paper planes, and I made different widths of wings. So let's say the first planes that I made had wings that were narrow wings. And then I made other wings that were wider. And then I flew them. And then I measured how far they flew. What's the independent variable? What's the variable that's causing change in the other? Yeah?
Wing width.
The wing width. And what's the variable that's changing because I changed the wing width? How far it flew. Okay? And most of you, if you haven't done it before, you might think the narrower the wings, the shorter the distance. It's more complicated than that in real life. Because if you make the wings too wide, what starts to happen to paper? It gets floppy, so it actually crashes. So the graph actually looks like it's like a hump. It goes up and then it goes down. There's like a perfect wing width. But it's a good example for me to just give you that everyone could get in their head. Now, line graphs. Line graphs are used to show variations between two quantities. Most often, line graphs are used to show variation in one over time. So in year 10, if you're doing a line graph, all I want to see is that time is on the x-axis. Why? Because line graphs are only appropriate when the independent variable is time, because the passage of time. Do you get a choice in how fast time moves? No, you don't have control over that. Okay? So when you connect the dots in a line graph, it's meaningful because time is always going to be on the x-axis, so it makes sense that those lines in between the data values are realistic. Okay? They mean something because time, you don't get to go backwards and forwards. So on a line graph, if the line points up to the right, then we say it has a positive gradient. If the line points down to the right, then it has a negative gradient, showing that the independent variable is decreasing over time. So I'll give you a few moments to get down to there to talk about positive and negative gradient. Then I'll do an example, and then lesson 2. Okay, let's do an example. The temperature in a yard I recorded every 2 hours from 6 a.m. to 6 p.m. The line graph below displays the results. Let's practice reading it. Hopefully you can see what I mean by you would know a lot of this. I'm crossing the T's and dotting the I's. I don't want you to be able to turn around and go, I wasn't explained a line graph for next year. Can someone tell me what the temperature was at 8 a.m.?
26 degrees.
Yep, because I literally look at the time along the bottom, then I go up. It was 26 degrees. Centigrade. What time was the temperature the highest? Someone else. 2 p.m. There's no steps to this. My formula would be, just freaking look at it, bro. Okay? When was the temperature increasing? Think about this. There's more to it than that. Was it increasing over a longer period of time?
6 a.m. to 2 p.m.
Yeah.
Was it increasing at different rates though?
Yeah.
Okay, so just keep that in mind. The question only asked, when was the temperature increasing? So yes, from 6 a.m. up to 2 p.m. But just be wary if it asks, when was the temperature increasing the fastest? You would look for the largest slope. So this one, it went across to up 3. This one went across 4, up 2. This one went across to up 2. So your fastest temperature increase is between 8 to 10. Okay? Then lastly, estimate would the temperature be at 5 p.m. How'd you get that?
In between 4 p.m. and 6
Yep.
p.m.
5 p.m.'s here. Look across. 27 degrees centigrade. And that also should show you why time is the only appropriate thing on the x-axis for line graphs. Because where on a line graph, you are connecting these things. So the time, you don't get a choice on how fast it progresses. So it makes sense that it would be a constant rate from one dot to the next, and you can read it off. So I'll stop the video there.